Welcome everyone. I'm Kamesh, CSE first year student in Jansen's Institute of Technology. Today I'm going to explain synthetic fuel advantages over natural fuel. In this topic we are going to see introduction, chemicals, synthetic fuel, natural fuel and then conclusion. First we will see about introduction. Fuel is a substance that is burned to provide nuclear energy, heat, or power. Materials like coal, wood, oil, or gas can provide heat when burned. Methanol, gasoline, diesel, propane, natural gas, hydrogen, or type of fuel. Nat- Nuclear energy is produced by burning plutonium. From fuel efficiency or fuel economy, we can measure how long any vehicle could travel, which is the opposite of fuel consumption. Fuel consumption is the amount of fuel vehicles uses to travel a particular distance. Fuel efficiency is measured in kilometers per liter. The efficiency with which the fuel does a conversion of energy is known as fuel efficiency. Let us understand the definition of fuel efficiency, and type of fuel in greater details. Here, the first known use of fuel was combustion of wood or sticks by Homo erectus nearly 2 million years ago. Throughout most of human history, only fuels derived from plants or animals' fat were used by humans. Charcoal, a wood derivative, has been used since at least 6000 BCE for melting metals. It was only supplemented by coke derived from coal as European forests started to become depleted around the 18th century. Charcoal briquettes are now commonly used as a fuel for barbecue cooking. Crude oil was distilled by Persian chemists with clear descriptions given in Arabic handbooks such as those who of Muhammad ibn Zakrai Razi. He described the process of distilling crude oil, petroleum into kerosene, as well as other hydrocarbons compounds in his Kitab al-Azhar, Book of Secrets. Kerosene was also produced during the same period from oil and bitumen by heating the rock to extract the oil, which was then distilled. Razi also gave the first description of a kerosene lamp using crude mineral oil, referring to it as the naphthah. Chemicals. Chemicals fuels are substances that release energy by reacting with substance around them. Most notably, by the process of combustion, most of the chemicals energy released in combustion was not stored in the chemical bonds of the fuel, but in the weak doubled bond of molecular energy. Chemical fuels are divided into two ways. First, by their physical properties as a solid, liquid, or gas. Secondly, as the basis of their occurrence. Primary, natural fuel, and secondary, artificial fuel. That's the general classification of chemical fuels. You can see here the picture of coal and gas and oil. Next, we come to solid fuels. Solid fuels refers to various types of solid materials that are used as fuel to produce energy and provide heating, usually released through combustion. And then wood was also extensively used to run steam locomotives. Both peat and coal are still used in electricity generation today. The use of some solid fuels, example coal, is restricted or prohibited in some urban areas due to unsafe levels of toxic emission. The use of other solid fuels as wood is decreasing as heating technology and the availability of good quality fuel improves. In some areas, smokeless coal is often the only solid fuels used in Ireland. Peat briquettes are used as smokeless fuels. They are also used to start a coal fire. Then we came into the topic of liquid fuels. Liquid fuels are compositably or energy generating molecules that can be harnessed to create mechanical energy, usually producing kinetic energy. However, there are several types such as hydrogen fuel for automotive users and ethanol, jet fuels, and biodiesels, which are all categorized as liquid fuels. Emulsified fuel of oil in water, such as emulsion, have been developed as a way to make heavy oil fractions usable as liquid fuels. Many liquid fuels play a primary role in transportation and the economy. Some common properties of liquid fuels are that they are easy to transport and can be handled easily. They are also relatively easy to use for all engineering applications and in home use. Fuels like kerosene are rationed in some countries, for example, in government substance shops in India from home use. Fuel gas. Fuel gas is any one of numbers of fuels that are gaseous under ordinary conditions. Many fuel gases are composed of hydrocarbons such as methane, and propane. Hydrogen, carbon monoxide are mixture thereof. Such gases are sources of potential heat energy or light energy that can be readily transmitted and distributed through pipes from the point of origin directly to the place of consumption. Then we came into the main topic. It is synthetic fuel. Synthetic fuel or syn fuel is a liquid fuel or sometimes gaseous fuel obtained from either syngas, a mixture of carbon monoxide and hydrogen, or a mixture of carbon dioxide and hydrogen. The syngas could be derived from gasification of solid feedstocks such as coal or biomass, or by reforming of natural gas. Alternatively, a mixture of carbon dioxides from the atmosphere and green hydrogen could be used for an almost climate neutral productions of synthetic fuels. As of July 2019, worldwide commercial synthetic fuels production's capacity was over 240,000 barrels per day. That means 38,000 meter cube by distance. With the numerous new projects in constructions or development such as carbon engineering. These are the common ways for refining synthetic fuels. It can be refined by three methods. First method is Fischer-Tropsch synthesis. Synthetic fuel can be produced from FT synthesis, a technology invented by Franz Fischer, and it can be refined by in the methanol to gasoline conversion also. The Exxon MTG process was introduced in 1975 as a means to convert methanol to gasoline. The initially published US patent US 404,414 in 1983 has been followed by at least 30 more, largely assigned to Mobil Oil prior to its merger with Exxon Corp. The methyl ether is then passed over a fixed bed shape selective ZSM5 zeolite to produce liquid fuels in 75% selectivity at 100% conversions. Accordingly, 90% of the carbon in methanol is converted to gasoline. The liquid fuels are C12 and lower, which is optimized for gasoline range. Next, method of refining is direct coal liquefaction. Direct coal liquefaction. Direct coal liquefaction involves containing coal directly with the catalyst at elevated temperatures and pressures with added hydrogen H2 in the presence of a solvent to form a raw liquid product which is further refined into product liquids. DCl is termed direct because the coal is transformed into liquid without first being gasified to form syngas. Many different processes have been developed for DCl, but most are aligned similarly in regards to reaction chemistry and the process concept. Common features are the dissolution of coal into a solvent followed by the hydrogenation of the coal with H2 over a catalyst. The process can be very efficient with an overall thermal efficiency in the range of 65%. Here we can see the diagram of coal gas qualifications diagram process in this PPT. Then we get into another main important topic is natural fuels. Coal, crude oil, and natural gas are considered fossil fuels because they were formed from the fossilized buried remains of plants and animals that lived millions of years ago. Coal is a combustion black or brownish black sedimentary rock formed as rock strata called coal seams. Coal is mostly carbon with variable amount of other elements, chiefly hydrogen, sulfur, oxygen, and nitrogen. Coal is primarily used as fuel. You can see the coal. And crude oil. Crude oil means a mixture of hydrocarbons and that exist in liquid phase in natural underground reservoirs and remains liquid at atmospheric pressures after passing through the surface separating facilities. And natural gas. Natural gas, also called fossil gas, sometimes just gas, is a naturally occurring hydrocarbons or gas mixtures consisting of methane and commonly including varying amount of other higher alkanes. The energy that the plants originally obtained from the sun is stored in the form of chemicals bonds in the gas. Natural gas is a fossil fuel. Here we can see there are known as the four natural gas and include the first four alkanes. These are the first four alkanes: methane, ethane, butane, and propane. You can see the chemical diagram of methane, butane, ethane, and propane. Then we came to advantages of synthetic fuel. The use of a synthetic fuel therefore has to have additional benefits. Low carbon sources has to be curtailed at certain time due to mismatch between supply and demand. And we came to advantages of natural gas. Natural gas is abundant and a major source of energy. According to the US Energy Information Administration EIA, the United States is flooded with natural gas with enough to last the rest of this century given 2018 production rates. EIA says there were about 2,276 trillion cubic feet of technically recoverable dry or consumer grade and infrastructure already in use is also advantages of natural gas. And we came into disadvantages of natural gas. There are natural gases, non-renewable resources, and it was disadvantages for storage purpose. Natural gas emits carbon dioxide. This is the by far the biggest disadvantages of natural gas. In the conclusion of this post, we will discuss how you can sustainably offset your natural gas usage with carbon offsets. And it is also another disadvantages. Natural gas can be difficult to harness. And we came to the conclusion part. Natural gas is unarguably a growing industry, and with further developments in technology is one that can certainly help pave the way to a sustainable future. If we keep on consuming natural fuels, we are destroying ourselves by consuming natural resources present in the earth. So we should start to consume synthetic fuel, avoid using natural fuels. Thank you guys. Thank you everyone.